drug-target interaction. As already discussed, my drug is going to interact with the molecular targets. Who are the molecular targets? They are nothing but carbohydrates, proteins, nucleic acids, lipids. In that, proteins are having a special importance because my proteins are going to act like a carrier molecule. They are going to act like a catalyst. So in here, I am going to elaborate how your enzyme is going to act like a catalyst. My catalytic function of an enzyme will be elaborated here. I told you my enzyme is acting like a catalyst. How it is going to act like a catalyst? There are two ways by which my enzyme is going to act like a catalyst. First way, my enzyme is going to provide one site to the substrate. That site is called as active site. See, I am enzyme. I am going to provide one site for the substrate. What is that site called? Active site. So, my substrate will come and bind to the active site of the enzyme. As a result, this complex will be easily attacked by the reagent. As a result, chemical reaction proceeds. I told you your substrate is going to bind to the active site of the enzyme. What type of bond is present between your substrate and the active site? It will be either ionic bond, hydrogen bond, van der Waals force of interaction or dipole-dipole interaction. So this is how the first way by which your enzyme is acting like a catalyst. What is the second way? My enzyme is going to provide functional group. The functional group will be attacked by the substrate. As a result, when substrate is ready, your reactant will come and attack it and your reaction proceeds. So the two ways by which your enzyme is going to act like a catalyst is enzyme providing active site for the substrate, then reactant comes, chemical reaction. Second way, your enzyme is going to provide functional group. The function group is going to attack the substrate. Substrate is ready, so reagent comes. As a result, chemical reaction happens. So this is how your enzyme is acting like a catalyst. Now, drug-enzyme interaction. We know what is the function of enzyme. If I am going to administer a drug, the drug is going to inhibit these two functions of the enzyme. How your drug is going to inhibit? We are going to see that. We have already seen the two functions of the enzyme. Now my administered drug will inhibit the two functions of the enzyme. How? My enzyme will block the binding, my inhibitor will block binding of the enzyme. So if I am going to administer a drug, my first step is this drug is going to prevent the binding of enzyme. If there is no enzyme, then no binding of substrate happens, so no chemical reaction. This is our first action of drug. What is the second action of a drug? The drug will be inhibiting the catalytic activity of the enzyme. This is how your drug is acting like an enzyme inhibitors. Okay. So you know what is a drug? Very clear. Drug is nothing but a small molecular weight chemical substance. If it is going to produce any therapeutic effect, then I am going to call that as a medicine. Okay, drug point is clear. Then what is the target of a drug? It is otherwise called as molecular target. My drug will be interacting with the nucleic acid, protein, carbohydrate or fats. Now I am going to take protein as a component because proteins play a very important role in wide range of the human body. So it is going to act like a carrier molecule, it is going to act like a catalyst. So how my enzyme is acting like a catalyst? Two ways. It is going to provide you a active site. Number two, it is going to provide a functional group. Now my drug is going to interact with the enzyme and it is going to block the two functions of the enzyme. How it is going to block the two functions of the enzyme? First function is my drug is blocking the binding of enzyme. If no enzyme, then no substrate can bind, so no chemical reaction. This is the first way. What is the second way? My drug is going to inhibit the catalytic activity of the enzyme. Since the drug is inhibiting the two actions of enzyme, from henceforth I am calling drug as enzyme inhibitors. Since the administered drug is inhibiting the functions of the enzyme, I am going to call my drug as enzyme inhibitors. Done. See, drugs are of several categories. How your drug will be acting as an enzyme inhibitor? One way, there are some drugs. What those drugs will do, they will be competing with the substrate. Say for example, substrate. See, I am having an enzyme molecule. Say for example, I am having an enzyme molecule. In this enzyme only substrate S should bind. But what happens? The drug who structure is chemically similar to that of your substrate will be competing with the substrate. As a result, instead of substrate, my drug will go and bind to the active site of the enzyme. So these drugs are called as competitive inhibitors. These drugs are called as competitive inhibitors because my drug is competing with the substrate and it is competing the substrate to bind with the active site of the enzyme. This is how your action of one kind of drugs. What is the action of a second kind of drug? See, not all drugs will be binding to the active site of the enzyme, but some drugs will be binding to the other site of the enzyme. Say for example, this is the active site. This site of the enzyme is called as allosteric site. What is this site called? This is called as allosteric site. Not all drugs will go and bind to the active site of the enzyme, but some drugs will bind to the other site of the enzyme called allosteric site. Done. If my drug is going to bind to this allosteric site, then the shape of the enzyme molecule is completely altered. My substrate cannot recognize my enzyme, so no chemical reaction happens. Done. So, till now we have seen drug, what is action of enzyme, how my drug is inhibiting the action of enzyme, then two kinds of drug interaction we have seen. My drug is competing with substrate to bind to the active site of the enzyme, then this drug is called as competitive inhibitor. Other kind of drugs will not bind to the active site, but they will be binding to the other site of the enzyme called allosteric site. When these kinds of drugs bind to the allosteric site of the enzyme, then the structure of the enzyme will be altered in such a way such that my substrate cannot recognize the enzyme, so chemical reaction will no longer proceed. Yes. See, my enzyme interaction with the inhibitor is by means of strong covalent bonds. My enzyme will be inhibiting with the inhibitor by means of a very strong covalent bond. These strong covalent bonds cannot be broken. As a result, your enzyme inhibitor complex cannot be removed. My enzyme will be completely blocked. This enzyme inhibitor complex will be degraded by the human body. As a result, my body should synthesize a new set of enzymes. Done. Whenever my enzyme is going to bind with the inhibitor, this complex is by means of a strong covalent bond which cannot be degraded. As a result, new set of enzymes should be produced. Now next is receptors. What is the role of receptor? My receptor will be acting like a drug target, and it is very important for communication process in the human body. My receptor will be present or it will be embedded in the cell membrane such that a small portion of the active site will be projected in the outside surface of the membrane. Say for example, this is the membrane. My receptor will be present or it is embedded in the cell membrane in such a way such that a small portion of the active site of the receptor will be present in the exterior. It is present outside the cell membrane and this is interior. Done. So your receptor is embedded in the cell membrane such that some portion of the active site is projected to the exterior. Now, a message between a neuron and a message between neuron and the muscle is carried out by chemicals. So these chemicals are called as chemical messengers. Done. Now I am going to elaborate the action of receptors. See, this is my receptor. My receptor is going to provide one site for the messenger. As a result, my messenger is binding to the active site of the receptor. When my messenger is binding to the active site of the receptor, then message is transferred to the cell without the messenger being entering inside the cell. This is an important aspect. I told you I have my receptor. My receptor is going to provide a site for the messenger. So my messenger will comes and blocks in the receptor's site. When it comes and interacts in the receptor sites, then message transfer happens. But my messenger didn't even enter the cell, but message is transferred inside the cell. Done. My receptor is having priority only for some messengers compared to the other type of messengers. So it depends on what factors. It depends on the shape of the messenger, it depends upon the structure of the messenger, and it depends upon the amino acid composition of the protein. So based on three aspects, my receptor will be giving priority to the messenger. Now, my drug acting like a receptor. See, this is my receptor. My receptor is going to provide a site for the receptor. So, my drug has interacted in the site of the receptor. Okay, done. See, this drug will be of two types. How? The drug will be inhibiting the natural function. As a result, it is called as antagonist, opposite. Okay, I have my receptor. To my receptor, my drug is binding to it. When drug binds to the receptor site, it inhibits the natural function of the receptor. As a result, here my drug is acting like a antagonist. Now, what is the, in which case this is very useful? This case is very useful when message transfer is not required, when message blocking is not required. In that case, this process is useful. What is the second type of drug? Here, my drug is going to mimic the messenger on the receptor. So, it is same like that of messenger. So, here my drug is called as agonist. It is going along with the messenger. Its function is same as that of messenger. So, here it is going to call as agonist. This case is useful when there is a lack of chemical messengers. Okay. So, we have seen what is a receptor. Your receptor is very important for communication process. Where its location? Its location is in the cell membrane such that a small portion of active site is present in the exterior. So my receptor is there, my messenger should come and bind to the receptor. When my messenger comes and binds to the receptor, then message is transferred without being messenger entering the cell. Done. Then my receptor is giving priority to some messengers compared to the rest of the messengers. This priority is based on the shape, structure and the amino acid composition of the messengers. Now my drug is going to bind with the receptor. The drug action will be of two ways. Either my drug will be inhibiting the natural phenomena, then that is called as antagonist, or my drug will be mimicking the action of a messenger. In that case, it is called as agonist. Yes.